Okay, so hi everyone, welcome to this webinar on career path in the turbomachinery field, which is being organized by the ETN Young Engineers Committee. Let me first say that this webinar is going to be recorded so that then we have it available for everyone that want to use it later on. Firstly, I would like to do an introduction to the ETN's Young Engineers Committee, the JEC or the YC, how we call it both, was born in 2020 with the main missions of creating a network of committed young engineers promoting fresh perspective for a sustainable world and society with a vision of facilitating a successful energy transition. So all the members of the YC has been preselected by their organizations, which are members of ETNs. And here you have actually the logos of all the companies that are well represented in the YC. And in the middle, you have pictures of some of us in the last annual general meeting in London. And in the middle, we also have Pedro, president of ETNs. So we are right now more than 40 members in the YC. We started only with just a few of us, and we see actually how it is growing and all the different things we are doing. So it's quite motivating to see how this committee is growing quite a lot in the last year and how we are achieving things being working together. With that, I would also like to present to you a bit about ETN Global. ETN stands for Energy and Turbomachinery Network. ETN is a non-profit organization that was born with the main vision of achieving safe, secure, affordable, and dispatchable carbon neutral energy solutions by 2030 and implemented globally by 2050. ETN is very much driven by its members, which are more than 135 already, and comes from all around the world, covering the whole value chain of the gas turbine technology. So ETN at the end of the day is creating the right platforms, is setting the right atmosphere to for successful cooperation and networkings, which is ultimately helping to achieve ETN's visions. Here in this slide, I'm also presenting to you ETN's technology development platform, which is being created in order to address the energy dilemma and is based on 5 pillars, which are product sustainability, operational optimization, decentralized energy systems, energy efficiency, and low carbon solutions. Around all that, we have different working groups, we have different committees, as for example, the Young Engineers Committee, who are working together in order to address the energy dilemma in each of these pillars. And just focusing on today's topic, it is very well known that many organizations and institutions belonging to the energy sector are encountering many problems to get young people to work in the turbomachinery field. And it is my experience that whenever I have met a young person who is working in this field, they are very passionate about it. And they are super motivated in trying to solve the problems that we are facing nowadays and in being responsible to solve the problems that will come in the next decades. So I strongly believe, and this is a shared thought with other members of the YC and ETNs, that the lack of young qualified people is because many are unaware of the different career paths that they can pursue in this field. Therefore, the main objectives of today's webinar is to successfully disseminate the different career paths that any of you can pursue, and you can have a very long and a successful career in this field. So the main objective of today is to disseminate the different career paths that are available. And in order to do that, I have invited 4 exceptional speakers, as you can see right now on your screens, and who works in different or who are specialized in different fields within the turbomachinery sector. Along with that, I also count on the help of ETN's Managing Director, Mr. Björkqvist, who is going to present today as well ETN's vision on this topic and will help with the questioning sections. So with that, I would like now to introduce to you Franco Rosatelli, who is going to be our first speaker. So Franco, if you want to start actually sharing your screen while I present to you, Franco Rosatelli, who is a former CTO of Ansaldo Energia. Franco worked for 35 years with Ansaldo Group, where he developed a broad experience on power generation technologies, both for nuclear and fossil power plants, directing for many years the research and development engineering department in Ansaldo Energia, and acting as Chief Technical Officer from 2009 to 2015. From 2015 to 2019, he joined REP Holdings from Gazprom Group in St. Petersburg, acting as Vice President for Technology Development. Franco has attained the status of a ETN Emeritus member since 2019. So thank you very much, Franco, for accepting our invitation. I look forward to hearing to you. The floor is yours.
Thank you. Thank you very much, Antonio, for your kind words. I apologize for deep voice because of some disease, but okay, I will try to do my best. As you anticipated, I am member of ETN Emeritus group since 4 years, but I've been for so many years also participating to all the ETN activities, IGTI conference, and all the other activities, annual meetings. So I always, on behalf of my former employer, my organization. So I know very well the contribution that ETN provided to gas turbine industry for so many years. And I am also very happy that with the recent decision from the board, the organization still keeping alive the acronym, but extended, I can say, the scope of, I can say, of the organization, including the 2 words about turbomachinery and energy, because we know that everything is bringing to these 2 very important aspects. And okay, I connected to the item which we will discuss today, which is really related to the need, to the importance to keep alive and to stimulate the presence of young engineers in the turbomachinery field. I skip to my next slide.
Perhaps you can put it in presentation mode, Franco?
Yes, sure, I will do.
Right. Thanks.
Okay, this you have already heard about this, so I skip to the next one, which is my first statement. I just try to synthesize in very few statements, which is, in my opinion, the real importance to have young people and to stimulate young people taking part to the opportunities to the related to turbomachinery career. First of all, I want to say that we know that there are growing opportunities for turbomachinery engineers in also in energy transition era. You know very well this picture, this graph, and you know that for sure, even in with the diffusion of renewables and I mean with the energy transition stimulation, natural gas still remain a very, very important key resource for power generation, and also the most important contribution in order to slowly reducing the diffusion and the contribution of coal power generation, which is still more than 1/3 of worldwide energy electricity production. So this is, in my opinion, the first statement that we need turbomachinery for power generation, but not only for power generation, because we also have for sure an increasing contribution from the market of for turbomachinery in mechanical drive. You know that the increasing contribution of liquid natural gas capacity diffusion already has a worldwide capacity of nearly 500 million tons per annum of potential gasification, which will be increased more than 20% during the next 5 years. So this is also this potential is very important for diffusion of turbo machines. Then I mentioned it for sure, nuclear power plants. These days we are discussing about the restart of nuclear production, nuclear power production. But independently from the technology, nuclear technology, independently from the cooling media, turbomachinery is still in the base of electricity production, also from these plants. And I also mentioned other examples like small turbines or also micro turbines, which are basis for the distributed generation and for the industrial use applications. So this is the first point. The second point that I want to mention.
I think you are muted now, Franco.
Okay, because innovation is both technological and process innovation. Maybe some of you, I am rather aged, but some of you maybe remember the investments in R&D effort we did in the 70s and 80s to find the alternative solutions for power generation. Alternative, I mean, to thermal cycle to overcome 60% efficiency. Nowadays, we have already with combined cycles, new plants, on the market, which are ready to offer guaranteed performance at above 63%. So this is a very important perspective, and it's a path to increase these plants, also in support for sure of renewable and energy transition. I mentioned it, but you know very well I didn't detail what are the most important trends for innovation. What is very important, in my opinion, for young engineers is to be aware that in order to have good opportunities in career path, it's important to be available for discontinuities and for changes. The last message that I wanted to share with you is that still related to innovation, the importance of innovation, is that we We have innovation very important in large organizations, which are still the key players in the innovation R&D process. But there is a growing opportunities, growing role, and also increasing opportunities for young engineers in also in supply chain companies and in technology-based startups, which can be also, for example, spin-offs from university and research centers. I just wanted to mention here, to list some of examples of this related to the fact that also big players on the market are aware about this, and they started since some years some relevant programs for the development and the stimulation of innovation based on small business. Here I mentioned, as you can see, Bakery Hughes, Engie, Siemens Energy, Enel, Equinor, Shell, but there are many, many others that you know. So finally, what I want to say is that from these three messages that I tried to share with you very quickly, comes my conclusion that I will really, from my more than 40 years of experience in power generation career, I strongly stimulate and I would like really to push young engineers to keep in mind that in spite of other opportunities for sure that can be considered, turbomachinery industry and also turbomachinery career anywhere in universities, in end users, is a very, very interesting opportunity. So thank you very much for your attention, and I am for sure available for any question.
Thank you very much, Franco. Yeah, thank you. I enjoy that. I was gonna say that since the beginning of this year, the YEC opened a close collaboration with the emeritus member of ETNs, right? And you are part of them. And for sure, we are already benefiting from that, and we are expecting to even benefit more as we increase the level of activities that we can carry together. So thank you very much for your speech. Then the next speaker is Karen Thole, a distinguished professor at Penn State Mechanical Engineering. Dr. Thole's expertise is heat transfer and cooling of gas turbine airfoils. She is currently directing the Steady Thermal Air Research Lab, which focuses on turbine heat transfer, advanced manufacturing, and instrumentations development. Thank you very much, Karen, for accepting the invitations, and the floor is yours.
Thank you, Antonio. Can you see my slides and hear me okay?
Perfect.
Okay, great. Well, welcome everybody. First of all, I'm really honored to be included in this session with such esteemed colleagues here talking about this important topic. And many of my messages are going to, just repeat a little bit what Franco said. This is the most exciting time in my experience to work in this field. And I can tell you that I'm jealous of all of you because you're just beginning your careers. And I wish I were at your spot because it's just such an exciting time because of this push on the impacts of what we do on the climate change. There's just so many more things that people are thinking about in terms of turbomachinery in particular. So I'm going to go through about 3 slides. The first slide is just to tell you what I'm passionate about and what I'm working on. The second slide, I'll give you a little bit about my career path and then talk a little bit about, maybe my own students and what they're doing. So first of all, I hope you recognize I'm an academic. I don't work in industry. I work very closely with industry, and I'll just say that I have the best job in the world, and mainly because it's the best job because I don't have a boss. And I get to work every day with very talented, bright students who just, bring joy to my life. So at Penn State, I run the START Lab, which stands for the SETI Thermal Aero Research Turbine Lab. And you can see that up in the upper left corner, and that little figure there, that's me. My students like to paste that in the figure so you can see the size of it. But it's essentially a one-stage test turbine. And the things that we're looking at is, we're trying to make this balance between, cooling the blades to make sure that they can last a long time, and how that impacts then efficiency of a turbine. This spans a lot of applications, including propulsion and power generation. So what we do is in the heart of very important things, both in those different applications. And so that's what we work on. You can see some of the measurements we make. We do detailed blade cooling studies where we can use an infrared camera, and we can capture the blade temperatures as they're spinning about 500 miles per hour, very fast. We can capture directly the stage efficiency. And then this is what's exciting, I think, about being at your stage of your career is all the new technologies that we can bring to bear in this problem. So some of the things that we're looking at are advanced manufacturing. We look at rim sealing, under platform sealing, which doesn't get a lot of press, but is really important to overall efficiencies between blades and vanes as they spin. We're looking at using CFD, and we're developing new measurement methods to quantify all the phenomena that happens in these very complex machines. Although I didn't put sort of machine learning on here, but that's certainly been that's been a new tool that we have used in our lab. And so all of these new tools that you are all learning about in your studies and in the early parts of your career can have a huge impact in our field in looking at things different ways. So I want to tell you a little bit about my personal journey, because I'm, as you're thinking about your own career, it's amazing, because I'll tell you some things that, careers are funny to look at. So I actually started my personal journey in a dairy farm in Southern Illinois, where I really didn't even know what engineering was. I had no idea. All I knew, there were farmers, there were teachers, and there were nurses. I lived in a town of about 800 people. But the one thing that my dad liked to do on Sundays, because there wasn't much to do on the farm, is drive to the local airport, which was in St. Louis, Missouri, and watch planes take off. And that inspired me. My dad liked it. I figured, man, this is pretty exciting to see a plane take off. So I think I'm going to work on this stuff. And I went off to the University of Illinois and did a couple of degrees there. And then I did my PhD at the University of Texas, and ultimately did a postdoc at Karlsruhe Institute of Technology. Now, one of the things I want to tell you between what happened in Texas and Karlsruhe is the fact that my PhD advisor told me, you should be a professor. You should start looking for an academic job. I was printing out the last chapter of my dissertation, and some of you may be in that same stage of your life or getting close to that same stage of your life. I was exhausted. Because that's how PhDs work. I was exhausted. I was tired. He came in and said, you should be an academic. And I looked at him and I said, being an academic will be the last job I ever take. And so the point of that is that, journeys can change along the way, and you should be open to thinking about your journey. You may have a plan in your mind, but, be open to other opportunities. Because when I went off and I did the postdoc at Karlsruhe, I realized how great it could be to be in academia, because I could choose my own career, my own direction in many ways. And really, maybe I got some sleep also while I was living in Germany. Maybe that was part of it. So after Karlsruhe, I actually started my career at the University of Wisconsin. And this is another lesson. For me, personally, the University of Wisconsin is a great institution, but it didn't have, let's say, the classes and the background, and it didn't have an emphasis on gas turbines. And I wanted to stay in the gas turbine field. I really enjoyed looking at, different ways to cool turbine airfoils. And so I moved to Virginia Tech, which was a better fit for my particular research group. I moved, my whole lab on a 53-foot transport truck. And we went down to Virginia Tech, and we were there for a long time. And mainly what I worked on are large scale, low speed models and learning about the physics that happens in a turbine. But when I came to Penn State, I wanted to make, and this was a big risk. And I would again encourage all of you, when the time is right, don't be afraid to go and take a big risk. So when I went to Penn State, I didn't work in large, low-speed wind tunnels, even though that was my training. I decided I was going to build a test turbine. I had no experience in doing this, but I had some sponsors who were encouraging me to do it, and I took a risk. I knew I could fail big, but luckily I had a lot of help around me, and I didn't fail. A great research professor to work with, and also great sponsors. So, the lesson here is don't be afraid to take risks in your own personal journey. And beyond that, we're taking another risk. We're building yet another turbine, which is now a 2-stage turbine, test turbine, and we just got an award for $26 million to do that in my lab. So that's pretty exciting. So the last slide I have, I think, if I can get this to advance. For some reason, it's not really. Oh, there we go. As I said, as a professor, what I get to see is tremendous talent coming through my lab, with lots of great ideas. And I learn more from I was reading one of my students' papers this morning, and I was learning a lot from him. And I can tell you that happens at the end of the degree program in particular. But our students are getting job offers at, all of these companies right now. And I would say, quite honestly, they're not even having to work to find a job. Okay. People are hiring them about a year before they're ready to graduate. They have multiple offers. They're good offers. And it's really an amazing time to work in this area. And for the young engineers on the line, I want to say one thing, and that is that what I think one of the reasons is not only that my students have this really incredibly strong technical background, but they have worked very hard, and I emphasize this, on great communication skills. And that's what sets them apart. And that's why they're getting these really great jobs. And so that is something for you all to think about as you go through your early career. Do whatever you can to develop your communication skills, because it makes a big difference for engineers to be able to communicate their work. So I think with that, I will stop sharing, Antonio, and turn it back to you. Thank you very much for allowing me to be here again.
Thank you very much, Karen, for that. I really enjoyed. You left many key points, which are actually very useful for development of our careers. So I really enjoy that. And sometimes we think a lot about how we can influence people, and we get crazy idea. We need a lot of money, but sometimes it's as easy as going to a school and tell them about a bit about our field, right? And then you get then inspired as you got, and then you finish working in this field. Thank you for that. Our third speaker is Sigrid Gijbels, who is a thermal fleet manager at Engie. Sigrid Gijbels has worked in the power industry for more than 25 years. Since 2022, she is working at Engie VU Flexible Generation Europe, where she holds the position of fleet manager for the thermal power plants in Belgium and the Netherlands, as well as for the first hydro pumped storage plants in the UK, Wales. Sigrid has also been appointed as a member of the ETN board. Thank you very much for accepting the invitation, Sigrid, and the floor is yours.
Okay, thank you, Antonio. Well, after the original equipment manufacturer, you had the academic world, and now you have a utility world. So basically, so I am working at Engie. I started working at Engie more than 25 years ago as a young engineer. Maybe a little word about Engie. So Engie is a worldwide organization with presence all over the world, with power plants, LNG terminals, desalination plants. So there's a lot of activities where turbomachinery is very important. So there are different type of professions in the energy sector. And to give the example of my career, so I started in Laborelec, which is one of the R&D centers of Engie. So I started as a junior expert in materials for gas turbines. It was the time in Belgium of the first overhauls on these gas turbines. So it was a very interesting time to learn, to investigate different topics, and so that's where I started. But of course, there are many other professions, and so there's also within Engie, there's also a lot of engineering companies like Tractebel, where they work on the construction of power plants, for example. So there's a lot of project managers, a lot of technical expertise again that is needed. But then there's also the other side, and that's where I am working now, more in the generation side itself. So we have all the different power plants where you can have jobs in operations, in asset management, in maintenance within Engie. In Europe, we have, for example, a European maintenance organization. So they execute overhauls on gas turbines, steam turbines, boilers, all the equipment. So they dismantle, overhaul, reinstall, all those kind of things. So there's a lot of engineers working in those organizations, and those are all really technical jobs, but with also a lot of opportunities to go into people management roles. So I think what's important, an important message for me is that you are at the start of your career, and I think you have to be aware that you are the directors of your own movie. So be active, look around, find something that gives you energy, because I think that's the important point. You need to find something that gives you energy, not something that costs you energy. And so for that, it is important to try maybe different things, and sometimes you may need to change companies, but within a company like Engie, you have the opportunity to do that without having to leave the company, because there's a lot of different opportunities. Another message I would like to give is also, well, be patient sometimes. Don't give up or quit too easy. Give yourself the time to grow. And especially if you start within a big organization like Engie, I think that is an important one. But as Karen Ann also said, it's a very interesting world, and there's a lot of challenges ahead, and we need good engineers that will help to find the solutions, and that's also something that is within the organization of Engie. There's also a lot of business development going on, so people working on developing battery projects, hydrogen projects. So those are all different opportunities that are possible. And on the other side, maybe the less technical side, or it's a different side, I would say. You have also opportunities in global energy management, for example. That's the trading of electricity, of gas. There's a commercial function. So there's a whole different range of activities and professions that you can try to explore. And the way we organized it within Engie is that so there's different ways of joining. You can have an internship, but they also focusing a lot the last few years on a traineeship program, which is really developed for the young graduate engineers. So they get the opportunity to explore for 2 years. They get different missions for 6 months. So you can have a job for 6 months within, for example, a power plant. You work in operations, and then after that 6 months you go to another job, maybe in business development, and then another 6 months in maybe in health and safety. And so you get the opportunity to get a lot of training. You get the opportunity to get to know the different possibilities. And then after that 2 years, you have a better idea of what you like, what activities are possible, and then you can make a choice on where you want to end up or what you want to do for the first years of your career. So that is something that is really pushed very much at the moment within Engie. You can, of course, also just apply on vacancies that are available. So I think I put here also an example of the way it is treated within the company. So if you we have a program on candidate care experience, so you can have a look at our website, look at the different vacancies that there are, and if you know what you want, you can apply for that job. But if you're not sure, then you can also get in contact with the recruiters, and they will help you to find within the list of opportunities to find a job that fits with your profile. So that's something that is stimulated within Engie. And I have put a movie at the end of my presentation, but I think I will not have time to show it. But I think the presentations will be shared with the participants, or I hope they will be shared, because this movie gives some testimonials of trainees that started to work. So I think it's very interesting for you that need to start your careers to get these first-hand impressions of some of your colleagues in this movie. So, but I will not show it because of the time, I hope you will be able to look at it after the webinar when the presentations are shared. So I now give the word back to. Oh, sorry. I now give the word back to Antonio.
Great. Thank you very much, Sigrid, for the presentation. Yes, we will share the presentation with the attendees. And now we're gonna go to the last speaker, who is our very own David Webb. David Webb is a senior rotating equipment engineer at DNB. David is an active contributor to the ETN Young Engineers Committee. Actually, David was one of the very few people that was there from the very beginning of the YC. And David has a strong interest in complex technologies. As a result of that, his international experience of 9 years in industry from the United Kingdom to Japan, David will provide us with some valuable insights on the careers in the field of turbomachinery. So David, the floor is yours.
Thank you very much, Antonio. Just, okay, let me know if you can see my presentation.
Yeah, good now.
Excellent. So after 3 great presenters, it's quite difficult to follow up on, but I've got a little bit of a different perspective in that, and maybe a little bit like Karen described earlier, I fell into turbomachinery, specifically gas turbines in the industry about 5 years ago. Not intentionally, well, a little bit intentionally. I loved it and stayed ever since. I'd like to tell you a little bit about that journey. So initially, I started off, so quite about 11 years ago, I studied mechanical engineering, and during that time, I'm from a very, even smaller than the 800 in the village for Karen. I came from a village of around 40 people, and I was just obsessed with leaving the UK. I was desperate to get out of the UK and see the world, and so during my degree, I studied abroad 3 different times, and in the 3rd year, I studied abroad in Singapore, and halfway through, they said, by the way, we don't do any classes in the 2nd semester. You'll need to find yourself a placement. Luckily, Rolls-Royce, which is the aircraft engine manufacturers, not the cars, they were setting up a new plant. And after a few emails and chats to them and an interview, I managed to get a placement with them and ended up working, so making the large blades at the front of the gas turbine, the spinny things you see on an aircraft wing. I was helping make those working in the heat treatment cell. Had an absolute blast, and that was a great introduction into the turbomachinery field with gas turbines, and then never returned to the aerospace or that industry ever again. So, but it was a fantastic time. That's not about them. That was simply about me and my journey. And once I graduated, I then joined D&V. And I joined as a safety consultant because I wanted to use engineering to make the world a safer place. And I was working within the energy sector with a lot of high risk hazards, and it was very intense work. I was still obsessed with leaving the UK, so I managed to get 3 placements similar to the Engie scheme that Sigrid described, moving around, working in different sectors around D&V, and I worked in 3 other countries as well. Had a fantastic time, learnt loads, and for my sins ended up back in England and working in Stockport in a small office. After all that travel, as well as working as a consultant, I was burnt out, to be honest. And I was looking for a new role that would provide a bit more of an engineering, and more consistency, unlike the consultancy I've been doing. And that's when I moved into the rotating machinery solutions team and working with gas turbines specifically, but in general, turbomachinery. Like I said, loved it, haven't looked back since. So I'm here just to talk about my role just now, a little bit about that. And so at 90% office work, 10% site work. For the office work, I'd say the majority is kind of handling the emissions, vibration, healthcare for a fleet of over 70 gas turbines that push gas into the UK, around it, and out of the UK. So these are the large, massive pipelines, and the gas turbines spinning around, spinning a compressor that pushes the gas around the UK. It's a lot of fun. I've got a great team, a small team that I work with. And talking about the site work that I do, this is we do some emissions testing of the gas turbine site. I think I've got a little photo I managed to take in a car park. I don't know why I got that photo. Another part, I've worked on some gas turbine consultancy projects in Hong Kong and Malaysia. And then I've also worked offshore, as they do use gas turbines offshore for power generation. There's a few photos of the team and some work offshore. It's been a fantastic time I've had there. That's my current role, and I'm welcome to any questions about it. Looking to the future, I'd say if I was to come into this industry at this point, rather than into about 5 years ago, just now it's a lot about decarbonisation, and currently working within the utilities. I'd say the future opportunities, the biggest one I see being talked about, or well, not being talked about, but just talked about, but being worked on, is the decarbonisation of the UK energy network. So this is talking about the large pipelines that get the energy, or the large power lines that get the energy from where it's generated to where it needs to be. Currently, it's natural gas is what's carried in these large pipelines. On the right, you can see a map of the pipelines and where the gas comes in currently, and when there's some pipelines you can see to Belgium and the Netherlands going across to there. That's the current system, which I work with. However, looking to the future, the idea is that, yes, we could do complete electrification. However, the amount of carbon we would spend and money to build the infrastructure would be massive. So why not just decarbonize this infrastructure that we have already? And that would mean pumping hydrogen around this network rather than natural gas. And that hydrogen to be renewably generated. That's the future that the industry is working towards. And there's a lot of research and a lot of innovation, and I'm sure Karen is probably working on it, or works with that as well. And the innovation comes to then decarbonize this network, so that we're pushing around renewable energy, whilst also not spending too much carbon or money to be able to have the infrastructure to do so. That's the end of my presentation. I hope I've made time. I'd say the last message from me would be, along with some fantastic messages from the presenters before, would be you might not know what you want to do right now, and that's okay. But if you keep trying new things and following your gut, hopefully you'll end up with a very fulfilling career, as I am now, that I have now. So thank you very much.
Thank you very much, David, for the presentations and your words. It's very insightful too. And now we are, before opening the question sections, I would like to share again my screen and give the words to Christer, who is the Managing Director of ETN, just to share with us also let me see where I have it. There we are. Who is going to share with us ETN's vision on today's topic. So Christer, the floor is yours.
Thank you very much, Antonio, and thank you all for these very inspirational messages and experience-based advices. I think that's very useful. I wanted just to showcase here just very briefly that the gas turbine is not only an important technology in the energy transition, but also in a carbon neutral society. Which we are striving for and trying to accelerate this pathway here. So I just wanted to show this. We put together this just to showcase all the different applications that actually would need a gas turbine, where a gas turbine can really help in enabling a gas turbine, a carbon neutral society. So if you see on this picture, his plot here, you see the gas turbine in the middle and you see different sectors. So maybe if you click on the next slide, next one, do you have that?
I don't
okay.
have it, Chris.
It's okay, so it's not, no worries. So first, I just wanted to, I just had to highlight it a little bit more. But if you go to the left side of it, you can see here harbors, for example, where gas turbine can play an important role in combined heat and power for industrial hubs. If you move up, then you can see the gas terminal, where also gas turbine will play an important role. Then you have hydrogen pipelines and compressor stations, and then of course power plant for both for following the load and also producing capacity backup. And then if you go further down on the right side, you see here the energy intensive industries, where gas turbines as mechanical drives can provide very important contributions. And then buildings and residentials, where gas turbine in distributed generation, microgrids, etc., can also play a role as combined heat and power. Then you have mobility, so of course aviation, but also in other heavy-duty vehicles, and finally sea transport, where maybe gas turbines driven by ammonia would be the most suitable solution. So there's a lot of different areas where gas turbine will play an important role, and it's up to us to all the young engineers to help accelerating this, so we as quick as possible can come into this situation. And in all these applications, basically, there's a huge demand for engineers and hand-on technical personnel. So if you look at it from, as have been described here also by the other presenters, from a research and development perspective, there would be a need for professionals in such as combustion, thermodynamics, material science, digital science, and also including the interesting area of additive manufacturing. In addition to these, engineers and technical personnel related to the operations, to condition monitoring, maintenance and service will also be, of course, crucial. And finally, I also wanted to say that one should also not forget the demand for electric and control engineers. So extending the demand beyond mechanical engineers. And as we also are considering in this future, will not only be a gas turbine there will be a lot of different technologies that will contribute, and gas turbine will be one of them. So the importance of integration is also something. So energy system integration engineers and technical personnel will also be very important. So I just wanted to showcase this and to highlight that this dynamic landscape offers a wide variety of opportunities and career pathways for any individual who would like to contribute to this evolving field of turbomachinery technology and energy solutions for a net zero society. So thank you, Antonio. And I think we're going into some questions now, right?
Yes, thank you very much, Christopher. Yeah, so now we have finished with the presentation from all the speakers. So we are gonna have like around 10 minutes for questions. I don't see any question in the chat, but I don't know if anyone would like to open their mic and ask the questions. Meanwhile, while we are doing that, I have also a ton of questions. I felt so identified with all you were saying. And I think one of the things that you said, Sigrid, is that, you know, we in these new generations, we always want something in a very short term, right? So we are almost asking for a soon return of whatever we do. And in your careers, this is something that you need to work for a lot of time to get some reward in different kind of things, right? So I quite like that you mentioned. But my question is now regarding, like, I made the statement that we might not fulfill all the positions that are currently opened because we are, or I believe that young engineers are not aware of what you actually said today. And many of you said that actually you didn't even know any about engineering when you were starting your career or when you were finishing your studies. So that was my statement. So what do you think? Do you think that we don't have enough young people into our field because they are unaware, or do you think there is something else? I'm just asking to see actually how we can help to solve that. So anyone who would like to take the questions, feel free to comment on that.
I can. Oh, go ahead, Sigrid.
No, go ahead, Karen.
Yeah. So I have to preface my comments always because this might be a U.S. centric view, right? But I would say here we have students who are getting incredibly excited about the space rocket business. Okay. Now, to me, this isn't near as exciting as what we work on, but okay, I think there is a big draw from our field into the space industry. And so I think that's one thing. It is interesting because we all work in such deep technical fields with such deep technical background that almost any field would want us in many ways. And for a while we had the, sort of all the people going to Wall Street, right? And because they were analytical and, understood some deep technical pieces of how to get things done, logical thinkers. Then we had, all of these people going to the .com business, right? The Googles and the Amazons and whatever. And now we're facing the space business, right? And so it looks like we are working in an old field, but that's why I think these sessions, and I really applaud you all for having this session, is to really show this excitement. And it's really kind of like a new day in many ways, because we really need to think about what we're working on in different new ways. So sorry to take too much time, but I don't know. That's how I've seen a lot of students.
Well, I think I can maybe react a little bit on that, because you say you see everybody going into space or looking at the space. What we notice within Engie is that we a lot of people want to work on the renewable side, and so for the as you say, old technology, it is considered it's polluting. It's old technology, so it's not sexy, if I can put it like that, for the young people anymore. But on the other hand, I think we still need the technology, and so I would challenge the young people to take up the challenge to help improve, and so the decarbonization, the new technologies that we need for that. So you can help to do that. And one of the trainees that we have, actually, she said at some point, she was a little bit disappointed because she got a 6-month mission in a thermal power plant. And afterwards she said, it was the most interesting one that I had from the 3 missions that I got in my traineeship. So I think it is a little bit, what is not known is not loved. So yeah.
definitely. So do we have any questions from the audience? Yeah,
Yes,
go ahead.
I want just to comment on what you said, just in connection to what Christer mentioned. We have to always to take in mind that we are thinking about mechanical engineers, but gas turbines and turbomachinery can open so much perspectives to such a wide area of engineering disciplines, because when I started my career, a control system with rather simple, I can say, system, and it was connected to electrical parts, which were also. But if we now think to the incredible potential for monitoring, for all the, I can say, application of artificial intelligence to the possibilities, big data use to analyze all the data. So we have potential for application and for strong interest for any discipline in engineering.
Thank you, Franco. I see we have a question here from Sony Aman.
Yeah. Yes. So he
Hello,
says,
guys.
yeah,
My name is Aman Soni. Aman is my first name,
Okay.
but it shows this in the other way, anyways. Well, I'm a mechanical engineer. I passed on 2007 batch from India, and thereafter I'm working for almost near to 15 years in mechanical engineering field. Started my career in EPC. Thereafter, worked for BBM Acoustic Technologies, which is basically German-based group, working on the static components like air intake, acoustic enclosures, silencers, and stuff like that. Thereafter with Donaldson, and now in Campbell. So I tried hard to get a job in Europe or America or some other parts of the world, because sitting in India is less like sitting in home, and I want to be outside the box. And naturally, more of the people were young engineers here over here would also try to do so in the future. But I found it hard to get one at least. So I would like to ask from the speakers of the day, what other course or some material or some study is required or something that I can take up to get at least a job outside my outside Asia at least. Yeah. Thank you.
I don't know. I don't think a specific study or anything is needed. I think you need to find a good opportunity and a good offer. But yeah, I don't know. I don't think specific studies.
probably he's asking more for the steps you can take in order to take a job in a different part of the world, no?
Yeah,
Because, yeah,
different part of
just
the
to put it easy, like when if you go to the, for many Spaniards, we go to the UK, right, to learn English and then to find a job there. If I want to find a job directly to the UK without being with my bachelor here and still in Europe, right, it's gonna be more difficult than if I go there, I do a master and then find a job. So he's kind of asking what are the steps that is gonna ease your transition from one part of the world to another to find a job, perhaps.
Yeah, I would add, so if I was in your position, it's about, I mean, there's two things that Antonio mentioned, like saying pick a country, like the UK, and doing a master's there, to then go on and have opportunities to come after that and find a job probably within the UK or somewhere within Europe. Also, another opportunity I would look at would be looking to work for international companies that are very international, just because they have those internal opportunities. It's always easier to move within a large organization than it is to join from the outside. So I think once you're in and the people are desperate for you in a certain country, if that's what you're keen for, that's an opportunity I'd look at. And that's the two things I can think of off the top of my head. But yes, either within an international company looking for internal opportunities, or going to study at a different country, and then after graduation, looking for other opportunities in that country.
David, I would say I'm already working in an international group. In the past, also BBM is a big group. It has a plant in India, in Germany, also I think in Canada. Donaldson is equally a big group in the field of air filtration, but I think I tried hard within the company also, but I would say it was my hard luck, or I could not see even a single person who is able to like move out of the local zone. So
Okay.
so I asked the question in an open forum, right?
Yeah, thanks for that. Yeah, I think we have another question in the chat as well. So he said, okay, thank you for your time and great presentation. The question is, how seamless is the transition from theoretical studies to the practical implications? And then open brackets, is it better to have hands-on diverse experience or to study profusely?
I think it depends on what kind of job you end up and what you want. Yeah, in general, well, the practical hands-on experience will come when you start your job. You can then choose to switch after a few years and try something different, or like I mentioned, within Laboralex or the research environment, there are people working in an expert role for 20 years or 25 years, and so yeah, it just depends on your profile and what you want.
So how is that managed in Engie, Sigrid? Like, because of course you need to first do these theoretical studies, right? Just to first see if it's an opportunity or not, and then in case you identify this, then probably there is another team. So how do you manage that within Engie? How is that managed? Do you know?
You mean for career opportunities or?
Well,
or
I mean
like
more
that,
from a practical point of view of having or seeing an opportunity to build a project or to do something, right? So you do some theoretical study or initiation study, and then if you see that actually the numbers works, you might bring that project to the next stage, right? Until you finish with the construction of a power plant or whatever. So I guess you have different teams doing this kind of things, no? It's not only one team like going from the very beginning to.
No, it's completely different teams. Yeah. And you can you can work in business development and develop the project for, I don't know, the construction of a new power plant, but that doesn't mean that when that project is approved and will start, it doesn't mean that you have to go to the project team that will construct the power plant. It can be different people. And then when the plant is constructed, that doesn't mean that you will have to work in operations or in maintenance of that plant. So you can switch and choose which path you want to go, but it's very much your responsibility, I would say. So there's a lot of opportunities, there's a lot of support, there's a lot of training options as well. There's an academy within Engie, a whole training organization, but you have to take it in your own hands. You don't have to wait until somebody comes and asks you, well, there's an opportunity there, are you interested to go there? You have to take action yourself.
Yeah. Thank you very much. So we are over time already. So I hope you didn't have anything else for, but let's say the last questions probably here that we have here. So here we have Numan, who is a doctoral student at Politecnico di Milano. He's working on supercritical CO2 axial turbine flow path optimization, and he's asking, can you also share how ML AI techniques are applied within turbomachinery field? And probably we can widen that questions. So he's asking for AI techniques in the design process of turbomachinery field. And this probably is one of the new technologies that we are seeing that are coming to our field, right? And this is related to what we were talking before, right? Because there were all the industries that, you know, are more proactive in taking in these technologies in a much earlier phase than probably our industry. So he's asking about how can we also apply these AI techniques into the design of turbomachinery?
Well, as a utility, I think we use AI technology tools in the condition monitoring, for example, the health monitoring tools and those kind of activities. So that's where the AI can play a role in our company.
Karen, Franco, David, do you want to add?
I mean, we do something similar. We are trying to monitor like part life and use that and use machine learning to tell, okay, this part life the part needs to be replaced, or, you know, trying to develop algorithms of what we can measure and how to relate that to part life, and trying to do that by using then machine learning as a platform for that. The other thing, of course, we've used machine learning for is, you know, coming up with new designs, like turbine cooling designs. There's lots of, you know, if you think about the design space, it's huge, right? And you've got to have a tool to sort of help you optimize it or whatever you need to do. So machine learning can play a big role there too.
Yes, I fully agree with the Karen about the potential to apply artificial intelligence to the design process. But another very important point which comes from my experience is about the availability from plants. I speak about OEMs, but it's a general possibility also for end users. The availability of such big data, such very wide mass of data coming from monitoring on the plants, which can be very difficult. It's very difficult to manage this data. We had a lot of problems to manage it without the support of new approach, and for sure the huge potential of artificial intelligence is one of the most important news in this field.
Yeah, very good. Okay, we have another questions. So it's okay for you to take another question, or you need to leave? I guess you need to leave because you are super busy. But if you need to leave, please do so. Don't worry if we will keep with the remainers. So, okay, here we have a question from Francesco Zatto from Politecnico di Milano. He's a master student. Could hydrogen be the ultimate true green fuel, and are there any interesting opportunity within the hydrogen field?
So I can take the first part, whether it's the ultimate true green fuel. I don't know the answer to that. But the second half of whether there's any interesting opportunities. So within DNV, we essentially we merged with GL, and they had a previous testing laboratory that was used for so kind of the energy sector, offshore oil and gas kind of hazards, blowing stuff up and setting it on fire and seeing what happens. And so you could just go there and say, right, I've got some funding from a client, or I've got an interest in this, and I'm going to get some funding from clients in the future for it. I want to go and blow something up and see what happens. And it's located in the middle of nowhere in northern England, and it's a lot of fun. I would recommend, if you can, getting there. But yes, so there's multiple people working within DNV who just get to do that every day and see what happens. So I'd say that's it's called Spade Adam. And I think there's some videos on YouTube you can see where they can just, various really explosive and flammable liquids and gases getting blown up, and then seeing what happens and conducting experiments and papers on that, as well as applying it to industry.
I think hydrogen is definitely a topic that is being looked at. Not only we're looking at hydrogen combustion in our gas turbines, and actually we've done the first MXL3 upgrade from Ansaldo on our GT26 in the Netherlands to make it ready for 50% hydrogen combustion. But for the moment, I think, yeah, well, the hydrogen is not yet there. When will there be enough hydrogen? So there's still a lot of work and a lot of challenges. So it will not be for tomorrow, but we definitely need to look into it. Will it be the most important one? I don't know. I think there are other opportunities. Christer already mentioned also ammonia combustion. So I think there's not one solution that we're looking for. We need a panoply, or how do you say it, of solutions, a whole range of solutions, because otherwise we will not get there.
Very good. Yeah, thank you very much.
Sorry, I was going to add at the end. I got excited about the blowing stuff up. The reason for blowing stuff up is to make it safer.
Yeah.
That's it's not just to explain. So it's like, if this is what it's like when you blow up natural gas. If we do it with hydrogen, does it have the same effects? Is it more? Is it less? That's what is a large part of the research going on there. But I realized I got excited about the blowing up and didn't explain why we do it.
That's a good point, David, to finalize this webinar. Yeah, I would like to thank all the presenters again. Thank you very much for attending and for giving so many insightful advices as well. I think as this is going to be recorded, I'm sure that we can use it for many other students to come, and I'm sure they will learn quite a lot because you gave a lot of key points. Thank you very much for all the attendees. I hope you enjoyed, and the Young Engineers Committee will go on organizing this kind of activities so it will help more with this topic. With that, I would like to say goodbye to everyone, and thank you very much. Enjoy the rest of your day.